And not all of them have you do this, and you won't have to do this on a test. But this one, just for when they ask you to do that on your homework, this one you're going to do y1 equals that value right there. 0.099x plus. Okay, so once you have that in there, you can go ahead and graph it. Mine's probably not still set, maybe it is. But I'll go to second, y equals to get my stat plot, just make sure it's still turned on. So it's on, I've got a scatter plot, L1 and L2, so that's good, okay. Just making sure nobody changed on me. So now that that's set, if I do zoom 9, I get my scatter plot that I did last time. You can kind of tell the lines kind of go up and to the right. They seem to cluster around that line that goes through it. And so now I've got my y equals line going through and approximating it so you can see exactly what that line looks like when you actually put it through. Like I said, that's not going to show up on the test, but you do have some like problems at the bottom that say graph them together. Technically, you don't even need to do this if you don't want to. Find the appropriate scatter plot, and then based on your slope and your y-intercept, you can kind of figure out what the line is supposed to look like. But if you do want to check it in your calculator, that's how you would do it. Put your least squares regression line into your y equals. Okay, and then they also have this warning down here. It says we can make predictions using the least squares regression line as long as your x value kind of fits in with all of the other ones that you see right here. So if you try to do it like over here, like a house that's maybe like 4,000 square feet, or a house that's really small, like 200 square feet or something like that, it doesn't really, your x values don't really line up, and it's so far away from the other data values that you really can't use it to make predictions anymore. And so when you do that, it's called extrapolation. And you don't want to do that because there's no guarantee that once you get out here to 4,000 that this trend stays linear. Like it's linear right here for these dots, but maybe once you get out so far, it maybe kind of plateaus a little bit and tapers off. So since we don't know what's going on out here because we don't have any observed values to verify it, once you get kind of past this part where all of your dots are, you can't really use that to predict it. So you can only predict kind of in this range right here, nothing smaller or bigger than it. Because like I said, you don't know that it stays linear. It might be something else. All right, so we're going to do the same thing that we did previous example, but now we're going to look at our drilling data instead. So I've got to fix my L1 and my L2, and we'll go through and calculate the least squares regression line. We'll use it to make some predictions. And then we'll draw our least squares regression line as well. So, just that edit. L1. Let's see. you do any calculations, just make sure your L1 and your L2 are the same length and they're not lopsided or anything like that. And once you've done that, you can go to Stat, Calc, go down to number 4 for linear regression, hit enter, you should get these values come up. If you are doing this, you should get your R and your R squared too. We talked about how to make sure those show up. If you're not getting an R and R squared, see me after class and we can turn your diagnostic on. Okay, so now if we look at our numbers for this one, I'm going to plug in my A and my B. My Y and my X I'm going to leave alone. So A is 0.012. I'm going to leave that as an X because it's my variable. And then my B is 5.527. Alright, so I plugged in my A and my B. My Y hat and my X, I'm just going to leave as variables. I'm not going to plug anything in them. For part A, I'm just going to leave it as a formula. So those are just from the screen on your calculator when you plug those in. Right, and then part B, once you predict the drilling time, if drilling starts at 130 feet, so whenever it's asking you to predict something, that means you're going to plug it into your least squares regression line. And they tell you it starts at 130 feet, that's the depth at which drilling begins. So in this case, our X is going to be 130. And like I said, whenever they give you one of these values, it's always going to be the X. They're not going to give you the Y. So if we just plug that value in, 012 times 130, that's 5, 7. 7.087. Okay, so this 7.087, this is what we would predict it to be. This is going to be our predicted value. And then another way it's going to be worded in your homework is if you do quite a few of these cases where X equals 130, you start 130 feet below the surface and you drill for 5 feet. The average time between all of the drillings that started at 130 feet below the surface, the average of them should come out to be about 7.087. And so this is our predicted value. It's also going to be the average time for all drillings that start at 130. Okay, so if you have 130 feet, some of them are going to be above this value, some are going to be below, but when you take an average of it, it should come out to be about 7.087 if you do it often enough. So with that interpretation, that's going to be how we look at this part right here, part C, because they word it kind of funny in the homework, but part C would say is the observed drilling time at 130 feet above or below average. So for part C, our average is 7.087. See, our average time is the same thing as the predicted time, 7.80. 7.087? Yeah, okay. So that's our average time, is the same thing as the predicted time for those ones. And so if they ask you the observed drilling time at 130 feet, so the actual observed time, this observed time is going to be from our raw data. Some people, when they say, is it above or below average, they know what they're looking at. So the observed time is the actual data value that they gave us at the beginning to start with. So anytime they talk about the observed time, That's from your table that they give you. It's the point that you actually see on your scatter plot. So if you look here, when it's 130, this particular time that we observed was 6.93. And so that's my observed time. It's going to be 6.93. That's from our table. So 6.93, is that above or below average? So it's below average. Because 6.93, our observed, is smaller than 7.087, which is our predicted, and that's also going to be our average. So you'll have those ones, they'll ask you about those on the homework question. Will just be a drop-down menu, you just select one. And then the last one, draw your least squares regression line on the scatter diagram. So I've got this one down here if you want to double check it when you're done. It should look about like that. But if you want to do it in your calculator, if you go to second, y equals your stat plot is still going to be set to what you want it to be. It's on, it's a scatter plot. You've got L1 and L2, so that's good. But now if you go to y equals your first equation right here, that's our old one. That's for the housing example. So we don't want to do that. Let's put in this equation here. Just update that, and then we'll be able to graph it and get an idea of what it should look like. So we plug in our new equation that we just found in part A. Now we can do zoom 9.